Okay, so this video is going to help you practice the scientific notation. We'll start off with some easy stuff and then we'll do some harder calculations. Now I recommend using the pause button. When you see a new problem up at the screen, hit pause. Give yourself a chance to try out each of the problems before you see and hear the answer. When you're all set, ready to go, hit the play button and then continue on. The weight of an alpha particle, which is emitted in radioactive decay of plutonium-239, is, lots and lots of zeros here, that many kilograms. Nobody wants to type that in your calculator, so let's try scientific notation. Remember, you want to move the decimal from here all the way over. Keep going all the way over till it gets right there. Not at the end of the number. It's got to go right here. So it's going to be 6.645 times 10 to the, then let's look at how many times we move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So we moved it 27 times. Now, if you check your answer, I know there's something wrong here, but just hang on. If you check your answer, does it make sense? You multiply 6.645 times 10 times 10 times 10 27 times. Should you come up with this? And the answer is no. But if you divide 6.64 by 10 27 times, then you will end up with this number. So it's negative 27 because that means divide. Alright, these are human skin cells. Humans shed about a lot of particles, 100,800,000 particles of skin every week, about 1.7 pounds a year. By 70 years of age, an average person lost 1.05 times 10 to the second pounds of skin. Alright, so here we go. Let's put this number into scientific notation. We'll take the other one out. 1.008. Again, we'll talk about whether or not you keep the other zeros later on. Now I don't mind if you keep them or get rid of them. 1, 2, 3, 4, 5, 6, 7, 8. So it's 1.08 times 10 to the 8th. And we know that's correct because if you multiply that by 10 8 times, you get this nice big number here. This one, let's take this out of scientific notation. We got 1.05. Decimal point starts here. It's saying take this number and multiply it by 10 twice. So multiply it by 10 the first time, multiply it by 10 again, and we end up with 105 pounds of skin by the time you're 70. Okay, again, put in and take out of scientific notation. This year we're going to deal with a lot of atoms and atomic structures and stuff, and we're going to deal with lots of little tiny structures here. So it says the radius is that big, or that small I should say. So let's put that into scientific notation. Move the decimal from here to there. 2.5 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10 to the 11th, and because it's a super tiny number and we divided the 2.5 by 10 to get there, we're going to hit or put in a negative sign. Okay? And then we're going to take this number out of. Now I certainly don't feel like writing that, but as long as you get the general idea, you're okay. It starts with 1.67. Then it says times 10 to the negative 24th. That negative 24th means divide by 10 24 times. Divide by 10, it gets smaller. Smaller, 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 smaller. You get the idea here. So I'm going to do that 24 times. And then fill them all in with zeros, and there's your answer. Okay, calculations are a little tricky. So let's work out a couple of these. I'm going to actually show you on the scientific calculator on my computer how to do them. But take a minute, take out your calculator, and let's see if you can do them first. So it says the number of times humans blink in a year. Get this nice big number here, 4,200,000. We're going to put that into scientific notation first. It says convert each into scientific notation. So 4.2 times 10 to the 6th. Then it says divided by. We've got to remember that. Divided by the amount of iron in the average 154-pound man's body. Let's put that in scientific notation. So it's going to be 6 times 10 to the negative 1, 2, 3, 4. So it's negative 4th. So we're going to take this number, put that in our calculator, divided by this number, put that in our calculator. So let's practice with an actual calculator and then we'll see what we get. Okay, so this is the calculator on my computer, but check out your own calculator. You might see either an EE, letter EE, or EXP button, and those are buttons specifically made just for scientific notation. So make sure you find those buttons on your calculator. If you can't find them, let me know. we never ever ever type in times 10. So here we go. We're going to put 4.2, and then instead of typing in times 10 after this, we never hit the times button, never hit 10. You're going to hit the EE button. Sometimes you might see something silly like this. It might be a big capital E's. It might be times 10. But either way, you're prompted now, instead of that 0, to fill in the exponent. So it's going to be 6. Now what do we do with it? We have to divide it by 6, and then we hit the EXP. Now we've got a negative exponent. It's going to be -4. So we hit negative, see a little negative up there, and then we type in 4. So now it's 6.e -4, and that basically means 6.0 or 6 times 10 to the -4th. And we hit equals, and there's our answer. Now you're asked to put it in scientific notation, so go ahead and try that. Final answer is 7 times 10 to the 9th. Okay, and there's no unit because it's just a silly problem. I'm just having you do these to practice putting numbers into your calculator and working with scientific notation. Later on, you'll have to check for units and put the appropriate unit in. All right, next one. It says an elephant can produce 50 pounds of manure a day, which could equal more than 1,280,000 pounds if the elephant lived past 70 years. So we're going to focus on this number. Let's put this one in scientific notation. 1.28, and then it's going to be times 10 to the decimal point goes here, 1, 2, 3, 4, 5, 6, 10 to the 6th. Multiplied by, let's keep that in mind. So it says in the mid-1990s, the world had an estimated 19,200,000 camels. So let's put this in scientific notation. 1.9, then we could put the 2. We'll figure out what to do with those zeros later on. So we got 1.9, 2, 1, 2, 3, 4, 5, 6, 7. So times 10 to the 7th. So we're going to multiply these new two numbers together. Let's work that one out. All right, 1.28, and then you're going to hit the EE or the EXP button. 6 times 1 point, and then it's 9.2 EE or EXP 7 equals, and put that into scientific notation. So it's going to be about 2.46. We'll learn whether or not we round and how many digits we have to round to later on. But it's 2.46 times 10 to the positive 13th. So there's your final answer for that silly problem. The average diameter of a red blood cell. So we've got the 7. We got to move this decimal from here past the 7. So we end up with 7 times 10 to the 1, 2, 3, 4, 5, 6. Now if I left it at 7 times 10 to the 6th, it would not be this number, because we're not multiplying 7 times 10 times 10 times 10 and so forth 6 times. That would be really, really big. So we have to say we have to divide the 7, and every time we divide the 7 by 10 it gets smaller, and we eventually end up with this number. So there's our first number. We're going to divide that by the speed of light, which is a number you'll get familiar with. 1, 2, 3, 4, 5, 6, 7, 8. So we've got 3.0 times 10 to the 8th meters per second. So let's divide these two numbers. Make sure you put this number in your calculator first, then this second. 7 EE6, the same as saying 7 times 10 to the 6th, divided by speed of light, 3 EXP or EE8 equals, never ever ever put a line over the 3. You're going to learn within a few days how to know how many digits to round to. There will be rules for this. Right now just put down 0.023 and then change that into scientific notation. Okay, so when you put this in scientific notation and record your final answer, you should put 2.3 times 10 to the negative 14th times 10 to the negative 14th. It's going to be a super, super small number. If we were to take this number out of scientific notation, we'd have to move the decimal point over there 14 spaces. So it's going to be 0.00000 and so forth. Really, really small. If you notice that you're off by 1 digit all the time in your exponent, it might be because you're typing in times, like an actual times button, and then the number 10. You never, never do that. You always put in the EE or the EXP button, and then you punch in just the exponent. You never, ever type in a times and a 10. All right, good luck.